Hello and welcome again to CHeM In 3. Today we look specifically at cis-trans or EZ isomerism, which is just one of the types of isomerism that we will be studying in IB chemistry. We'll be dividing isomerism into stereoisomers and structural isomers. And stereoisomers can be divided into configurational and conformational isomers. And configurational isomers is subdivided into optical isomers, and cis-trans, or following the IUPAC, EZ isomers. Let's take a look at this example here, and it says that this shows no isomerism. The examples that we are going to focus on would include only alkenes. So here we have a typical alkene with one double bond, two carbons, and four groups designated R1, R2, R3, and R4. Now, for you to have optical isomerism in this particular example, you can put an imaginary line through here, and then designate this as R1 and this as R2. And once you have a situation where R1 is the same as R2, or if R3 were the same as R4. In these cases, you would have no isomerism, no cis-trans or EZ isomerism. But in a case like this, where R2 is now an OH group, a different group from R1, so R1 is not the same as R2, and R3 is not the same as R4. When you have that situation, then you would have isomerism, and then you must follow the Kahn-Ingold Prelog rules from 1966, the CIP rules, to decide whether you have an E version of the isomer, which is represented in italics and in brackets, or a Z version of the isomer. And to designate the isomer as either an E or a Z, again, we put this imaginary line down the middle, and we compare R1 to R2. And here we see that R2, because it's attached to an oxygen that has a higher atomic mass than this hydrogen, the higher priority group is here, on this side of the molecule. And over on this side, Cl is much higher in its atomic mass than C, the first atom attached here. So therefore, this is the higher priority group on this side. And once you have the two HPs, the two higher priority groups, on the same side of the double bond, then you have a cis isomer or a Z isomer. And if it were that the Cl were on this side and the CH3 on this side, then the higher priority group would be on that side, and on this side the higher priority group would be below this line. In such a case, this would now be designated the E version of the isomer, or the trans version of the isomer. So now, I would like you to take a look at this molecular model, and to note that the red represents oxygen, this green represents chlorine, and the whites represent hydrogen, with the blacks being carbon, and this being your typical double bond of an alkene. How would you classify this isomer? E or Z?
Let's take a look at the answer to this question now. Drawing a line down the middle here, we can see that R2 on this side has a higher priority than R1, owing to the fact that oxygen has a higher atomic number and relative atomic mass than hydrogen. So the high priority group, the HP, is on this side. And looking at this side of the molecule, here we see that the higher priority group is R3, because chlorine has a higher priority than oxygen. So with the two high priority groups on opposite sides of this line here, and one HP group here and the other one here, on opposite sides of the molecule, here and here, then we designate this the E isomer or the trans isomer. Now I would like you to take a look at these examples.